The first week of the Colorado Earthship build was a rigorous yet rewarding experience, marked by the collaborative effort of professionals, students, and volunteers. Progress began with constructing the tire wall, an essential structural element and the backbone of the house. This process involved repurposing discarded tires, which were filled with a dense mixture of gravel, earth, and a concrete-like blend for strength and durability. Each tire was meticulously packed using sledgehammers in a demanding, labor-intensive effort that challenged the stamina and teamwork of the crew. Over 500 tires of various sizes were carefully selected and organized, with the largest ones positioned at the base to ensure a robust foundation. Stacked 8 high, the tire wall began to form the distinctive shape of the Earthship, its curved structure designed for stability and aesthetic appeal. Adjacent to the tire wall, workers created a thermal berm, a substantial mound of soil strategically positioned behind the structure. This feature, built using heavy equipment like backhoes, plays a pivotal role in the Earthship's performance, acting as a natural insulator. The thermal berm stabilizes interior temperatures by retaining heat in winter and keeping the house cool in summer. To maximize energy efficiency, the team installed vapor barriers and additional layers of insulation, ensuring the home's resilience against temperature fluctuations and moisture intrusion. The second week of the Colorado Earthship build saw a shift in focus toward earthmoving and the groundwork for the water system, a critical element in the self-sustaining design. Heavy machinery such as excavators and backhoes became the stars of the week, aiding in the monumental task of shifting massive quantities of soil. One of the primary objectives was to prepare trenches for the installation of 4 1,750-gallon cisterns, which are essential for the Earthship's off-grid water system. These cisterns are designed to collect and store rainwater harvested from the roof, capable of holding up to 9,000 gallons in total. Careful measurements ensured that the trenches were deep and level enough to securely accommodate the tanks. The placement of these cisterns was carefully planned to optimize gravity-fed water distribution throughout the house, ensuring reliable access to water for household use, including drinking, cooking, and gardening. In addition to the trenching, large quantities of dirt were moved to backfill areas around the tire walls, which had been completed in week 1. Backfilling serves 2 key purposes: stabilizing the walls and further insulating the structure. This process involved not only heavy machinery but also a significant amount of manual labor, as workers used shovels and wheelbarrows to refine areas the machines could not reach. The team also prepared the site for future structural elements, such as floors and interior walls. By leveling and compacting the soil, the week wasn't without challenges. One recurring issue was equipment setbacks, including a damaged camera lens that had suffered from repeated falls during the intensive work sessions. However, the team remained resilient and focused. Each obstacle became an opportunity for creative problem-solving, with volunteers and professionals combining their efforts to overcome difficulties and keep the project on track. Despite the physical demands and technical challenges, the week was a major success. The trenches for the cisterns were completed, and the foundational work for the next phases of construction was laid. The third week of the Colorado Earthship build marked a critical milestone as the focus shifted to constructing the roof. With the tire wall reaching its final height, attention turned to the installation of massive wooden beams, or vigas, that would form the primary structure of the roof. This phase demanded precision, strength, and an extraordinary level of teamwork. Each viga, weighing around 1,000 pounds, was lifted into position using a crane, a task that required careful coordination between the machine operators and the crew on the ground. Rory, a seasoned foreman with 25 years of Earthship building experience, oversaw the operation with an expert eye, ensuring both safety and accuracy. Rory's calm demeanor and extensive knowledge proved invaluable, especially when challenges arose, such as aligning the vigas perfectly atop the tire wall to ensure a stable framework. On the ground, teams worked in synchronized efforts, guiding the beams into place as the crane lifted them overhead. Workers secured each beam with temporary braces before leveling them to maintain consistency across the structure. Once positioned, the vigas were anchored firmly to the tire wall, forming a solid foundation for the roof. The crew's combined strength, careful planning, and Rory's leadership made this intricate process both efficient and safe. With the roof framing in place, the team moved swiftly to add layers of insulation and waterproofing. The insulation, made from a mix of rigid foam and natural materials, was critical to the Earthship's thermal performance, ensuring it could retain heat during winter and stay cool in summer. On top of the insulation, waterproofing membranes were installed to shield the structure from rain and snow, ensuring durability and longevity. This phase of construction also required attention to the aesthetic integration of the roof. The vigas, often left exposed on the interior, would eventually serve as a striking architectural feature, highlighting the Earthship's blend of functionality and beauty. The completion of the roof framework was a celebratory moment for the team. It signaled a shift from foundational work to the more visible aspects of construction, where the Earthship began to resemble a functional home. The final phase of the Colorado Earthship build focused on turning the structure into a functional, livable home. With the main construction complete, attention shifted to finishing touches, which combined practical systems with artistic flourishes, showcasing the unique character of the Earthship design. The walls were plastered using a mix of natural and synthetic materials to create smooth, durable surfaces. Earth-based plaster was applied to interior walls, giving the spaces a warm, organic feel while helping with thermal regulation. Exterior surfaces received weather-resistant finishes to protect the structure from the elements. Volunteer artists and craftsmen added decorative touches, embedding colorful glass bottles and tiles into walls, creating vibrant, light-filled patterns that reflected the spirit of sustainability and creativity. Flooring was installed next, using a mix of poured adobe and polished concrete. The thermal mass of these materials not only added to the house's energy efficiency, but also gave the floors a clean, modern appearance. The plumbing and electrical systems, pre-installed during earlier phases, were connected and tested. Fixtures, including energy-efficient LED lighting, solar panels, and rainwater filtration systems, were finalized to ensure self-sufficiency. The cisterns were fully operational, allowing the Earthship to collect and utilize rainwater for household needs, while the photovoltaic system provided renewable energy to power the home. Lastly, landscaping and exterior details completed the project. The team planted drought-resistant native vegetation around the site to restore the natural environment and enhance the house's integration with its surroundings. Pathways, constructed from reclaimed materials, tied the exterior design together. By the end of the finishing process, the Earthship stood as a testament to sustainable design, blending functionality with artistry. The home was ready to provide its occupants with comfort, efficiency, and harmony with the environment for years to come. The global environmental crisis has spurred innovative solutions in architecture and sustainable living, with one creative trend being the construction of eco-houses using recycled car tires. This approach combines environmental conservation with cost-effective housing, transforming waste into a resource. Recycled tires, often viewed as a disposal problem, are repurposed to create sturdy, insulated, and environmentally friendly homes. Car tires are made from durable materials like rubber, steel, and synthetic fibers that are designed to withstand wear and tear, making them notoriously difficult to decompose. It can take hundreds of years for tires to break down in landfills, where they can release harmful chemicals into the environment. Burning tires is equally problematic, emitting toxic fumes and greenhouse gases. These issues have prompted architects, environmentalists, and homeowners to explore sustainable ways to repurpose tires, and eco-houses offer an ingenious solution. Why use tires for eco-houses? Durability and strength. Tires are incredibly robust, capable of supporting heavy loads, and they maintain their integrity over time. When filled with compacted earth, they form solid, earthquake-resistant walls that can bear significant structural weight. Thermal insulation. Earth-packed tires have excellent thermal mass properties, absorbing and storing heat during the day and releasing it at night. This natural insulation minimizes the need for artificial heating or cooling, reducing energy consumption and utility bills. Abundant and low-cost material. With millions of tires discarded annually, they are a readily available and inexpensive building material. Many waste management facilities are willing to give away used tires for free, cutting construction costs dramatically. Environmental impact: reusing tires reduces waste and mitigates the environmental hazards associated with their disposal. It also lessens the demand for conventional building materials like cement, which has a significant carbon footprint. The construction process: building an eco-house with recycled tires involves several key steps. Design and planning: the first step is to design the structure. Most tire-based homes, such as Earthships, incorporate passive solar heating and natural ventilation to maximize sustainability. They often include features like rainwater harvesting and renewable energy systems. Tire preparation: tires are packed tightly with earth or sand using tools like sledgehammers. This creates dense, stable units that can be stacked like bricks. The packing process ensures that each tire becomes a load-bearing component. Wall construction: the tires are laid in overlapping rows similar to bricks to form walls. Gaps between the tires are filled with earth or plaster, creating a smooth and seamless surface. Reinforcement with rebar or wire can add extra stability. Roofing and finishing: once the walls are complete, conventional or sustainable roofing materials, such as timber or metal sheets, are added. Interiors are often finished with plaster or clay to improve aesthetics and further insulate the house. Sustainability features: many tire houses integrate eco-friendly elements like solar panels, composting toilets, and gray water recycling systems. These additions enhance the self-sufficiency of the home and reduce its environmental impact. Modular log homes by Cozy Cabins. Rustic charm meets modern efficiency. Are you dreaming of owning a custom log home? Cozy Cabins brings this dream to life with their expertly crafted modular log homes, designed for clients throughout the Northeast. These homes seamlessly blend rustic charm with the benefits of modern modular construction, offering a faster and more efficient path to your dream home. A streamlined approach to log home construction: every modular log home by Cozy Cabins is constructed in a state-of-the-art climate-controlled facility. This controlled environment ensures exceptional quality, minimizes the risk of weather-related delays, and maintains precise craftsmanship standards. Unlike traditional construction methods, where work is often hindered by adverse weather conditions, Cozy Cabins' method ensures reliability and efficiency. Once the home is constructed in large sections, it's delivered to the job site with features like kitchens, bathrooms, flooring, and lighting already installed. Specialized delivery equipment makes it possible to transport these modules to even the most challenging build sites. A crane carefully hoists each module into place, setting it securely on a pre-built foundation system. Innovative design and versatility: Cozy Cabins employs modern modular techniques to make the construction process both versatile and efficient. For example, roofs are transported flat and then hinged into place once the modules are installed on the foundation. Other key elements, such as panelized gable walls and peak sections, are pre-designed and installed after the roof is secured. Customization is at the heart of the Cozy Cabins experience. Buyers can tailor their log homes to suit their unique preferences and needs. Optional features like dormers enhance both functionality and aesthetics. Rear shed dormers expand usable upstairs space, while A-frame dormers provide additional natural light and visual appeal. The front porch is a quintessential feature of any log home, and Cozy Cabins ensures this charming detail is standard on every model. Homeowners can customize their porches, like opting for a 10-foot depth to create an inviting outdoor living area. Inside, Cozy Cabins' modular log homes feature a standard knotty pine interior with a clear finish. This finish enhances durability, creates a warm and inviting atmosphere, and even imparts a delightful natural aroma to the home. Kitchens, crafted by local artisans, come ready for use and offer a perfect blend of functionality and rustic style. For additional living space, many homeowners opt to place their modular homes on full basements, which can be converted into game rooms, home offices, or extra bedrooms. Cozy Cabins offers a variety of roofing options to suit individual tastes and practical needs. One popular choice is the standing seam metal roof, known for its durability and clean aesthetic. After the home is delivered and assembled, crews complete the interior trim work and upper ceiling installations. Within just weeks of delivery, your home is ready for you to move in and enjoy. Cozy Cabins' modular log homes combine the beauty of rustic living with the efficiency of modern construction techniques. Whether you're looking for a cozy cabin retreat or a full-sized family home, the company's skilled team can customize a design that fits your vision. From initial planning to final assembly, Cozy Cabins ensures a smooth and satisfying experience for every homeowner. Basement construction is a critical phase in the development of any property, requiring precision and careful planning. In a recent new build project in Portsmouth, advanced technologies and sustainable solutions are being integrated into the design, including energy-efficient systems and renewable energy features. The basement construction begins with site preparation, including excavation and soil stabilization to ensure a solid foundation. Proper drainage systems are installed to prevent water ingress, a common challenge in below-ground structures. Advanced waterproofing techniques, such as tanking or cavity drainage systems, are utilized to protect the basement from moisture, ensuring a dry and durable space. Structural reinforcements, including reinforced concrete walls and floors, provide strength and longevity to support the entire building. This project also incorporates innovative energy solutions to maximize efficiency and sustainability. Earthship products, especially, is contributing their ESP Heliotherm Sensor Comfort Compact System, an 8 kilowatts underfloor heating solution designed to perform optimally even in cold conditions, down to -7 degrees Celsius. This advanced system offers consistent heating throughout the building while reducing energy consumption. Additionally, a 300-liter EcoScent unit is integrated into a mechanical heat recovery ventilation (MHVR) system, which not only provides hot water but also ensures proper air circulation and heat recovery. This holistic approach maintains comfort while minimizing waste and energy loss. To further enhance sustainability, the property will feature a 4 kilowatts photovoltaic PV array for solar power generation. A Tesla Powerwall battery will store surplus energy, allowing the household to use it during periods of low solar production, effectively reducing reliance on the grid. The basement construction and the integrated energy solutions in this Portsmouth project exemplify modern building practices that prioritize efficiency, comfort, and environmental responsibility. Building with insulated concrete forms, ICFs, offers an efficient and durable solution for constructing energy-efficient walls. Here's a detailed guide on stacking, cutting, and reinforcing ICF walls, based on a real-life project involving a basement and a circular tower. Once the footings are poured and set, the process begins by stacking the ICF blocks. Start at the base, aligning the blocks carefully. Many ICF systems, such as BuildBlock, are designed to interlock securely, making the stacking process straightforward. In cases with varying wall heights or stepped foundations, pre-planned height intervals simplify the task. Drop each block into place, ensuring a snug fit. For unique architectural features like circular towers, specialized radius blocks are available, which enable smooth curves. These blocks work similarly to standard blocks but are pre-molded to create the desired circular structure. During stacking, integrate horizontal rebar reinforcement as specified by your engineering plan. These reinforcements are crucial for the structural integrity of the wall, especially in areas subject to high loads or seismic activity. Once the blocks are stacked, install vertical rebar reinforcements. Scaffolding and bracing are essential at this stage, not only to stabilize the walls but also to provide safe access for working. Position the vertical rebar between courses, ensuring proper spacing and alignment. Horizontal and vertical rebar often overlap or alternate between courses to create a robust reinforcement grid. Proper installation of rebar is critical for the strength of the wall, so take time to inspect your work. Gaps, misalignment, or improperly tied bars can compromise the structure. Customizing the ICF blocks is necessary when the wall height or design deviates from the standard block dimensions. Use a table saw for clean and accurate horizontal cuts. For taller cuts beyond the saw's capacity, finish the process with tools like a sawzall or nippers. When trimming blocks, focus on preserving the structural webs inside. For example, in this project, only the top triangle of the web was cut to avoid weakening the block's integrity. Removing too much of the web could reduce the block's strength and stability. In projects incorporating ICF decking systems like BuildDeck, careful preparation of the top course is vital. Once the main wall height is reached, trim the top course of blocks to accommodate the decking system. In this case, the builders cut the eighth course of blocks down to 4 inches, providing a precise base for the build deck panels. Ensure the cuts are clean and level for proper seating of the decking. After stacking, cutting, and reinforcing, inspect the entire assembly for gaps, misalignments, or improperly set blocks. Proper bracing ensures the walls remain stable during the concrete pour. Always follow manufacturer guidelines and engineering specifications to achieve optimal results. In this project, the basement walls were built to a height of 9 feet 4 inches, topped with an 8-inch build deck slab. This approach provided a solid and well-insulated foundation for the hilltop house.